Hello, everyone, and welcome to our session, Asset Management Digitalization. I'm Inder Preet. I'm a senior analyst with ARC, and I cover asset management. So we have a number of speakers today, excellent speakers and panelists. They're going to introduce themselves as they come on stage. But if you want to take a look at their detailed bio, it's available in the ARC Forum app that we have. So let's begin with our presentations for today. So I want to start off the discussion today by talking about the challenges that we see in the industry and why do we need asset management. Well, to this group, I'm pretty sure that I don't need to go over the benefits of asset management, that we need it to reduce unplanned downtime, increase productivity, increase profitability, sustainability, and safety for our workers. But when we go out in the industry, we see a little bit of a different story. When it comes to APM efforts, I think we can do a little bit better. So at ARC, we try to talk to end users from time to time to understand what they are thinking, what they're doing. And we ask them that what is the current state of their asset performance management, or in short, we call APM initiatives. And we realize that a lot of them are just developing their strategy right now. About 40% said they are working on this strategy, and about 1/5 said they will develop a strategy in future. And this whole survey was about APM. Still, about 8% said they do not have any plan about APM strategy. So was a bit surprised to see that. But when it comes to technology, I think we have certainly come a long way. Years ago, when we were at the bottom of it and were doing all manual processes and reactive maintenance, now we have a number of options available to us based on the criticality level of the asset, the importance of the asset. We can choose from either we want to do a planned maintenance, preventative maintenance, predictive maintenance. And we have also started to see some use cases around prescriptive maintenance, which we put at kind of the highest level at level 5. So in terms of technology, we have come a long way. And APM is not only about our traditional practices and applications. It's much more than that. We can integrate our APM systems with other systems to use the data, to use the knowledge that we have. We have digital tools like augmented reality, robots, drones available to us to optimize our asset management. And we have tools and we have the visibility to link our APM initiatives with our business goals directly. So technology has taken APM to next level. And we asked our end users, among different technologies, what are they implementing and what are they planning to implement? Condition monitoring, or EAM, CMMS, we can consider them kind of traditional APM tools. A lot of them are already using that. Some of the technologies that they are more interested in includes analytics, machine learning, and few others as well. And then we ask them, what are their greatest challenges? And constantly, year after year, one thing that we hear is that integration with other systems. They want to integrate their APM systems with other systems to leverage the data, leverage the knowledge. And still, it remains a challenge. Adoption of advanced technologies is a major challenge. We all know the benefits of these technologies. We want to adopt that. But how do we adopt these? This remains a major challenge. So today, in our session today, we'll hear from end users who are already on their asset management digitalization journey. And they are dealing with these challenges. They are having some successes. And today, we'll get to hear from them what they're doing and how they're doing.
Thanks very much, Preet. It's really great to be back at the ARC in person after a couple of years of hiatus. So, Maulik Patel, I'm with Dow. I'm a senior director. I'm leading Dow's digital manufacturing acceleration program. And I'm also leading the run and maintain organization within the operations IT/OT team at Dow. A little bit about Dow. Our ambition is to become the most innovative, customer-centric, inclusive, and sustainable material science company in the world. So Dow's portfolio of plastics, industrial intermediates, silicones, and coatings delivers broad range of differentiated science-based products and solutions uh, to our customers in high-growth market segments such as packaging, mobility, infrastructure, and consumer applications. Dow's global scale, we have 106 manufacturing sites in 31 countries. 12 innovation centers. Our 2021 annual sales was $55 billion. So you can see the footprint here, and the things that I'm going to talk about, it's kind of figuring out how do we implement the digital technologies in this global footprint. As it relates to this topic, I'm going to talk about the Digital Manufacturing Acceleration Program, which is really part of the overall Digital Dow strategy, which is designed to improve our employees and customer experience. So by implementing digital technologies and the corresponding work process optimization, we are committed to improve reliability, our safety, and also the productivity of our sites and the assets. So the investment that Dow is making here in this digital journey is expected to make direct contributions to the value case that we have put together, both towards the growth and productivity. So what we are really going after when it comes to growth is to have increased capacity. So make more pounds, run your asset better, make more pounds with what you have without making additional investments, and then significantly improve product supply reliability. Well, what does that mean? Make and have what your customers needing, and make sure you deliver to them when they're expecting. And then go ahead and do contribute towards cost reduction. So reduce the cost for materials and supplies, significantly improve the way we do the maintenance and operations, so improve those workflows, and by doing that, overall increase labor productivity. So there's a lot expected from the investment that our company is making, and the question is, how do you go about doing that? So we are starting first with deploying what we call foundational enabling capabilities. So if you look at the bottom rung of the slide on the left, the first thing that we are doing is implementing a central data repository, what's called integrated data hub, that's fully secure, scalable, reliable, and cost-effective. And that's just not for manufacturing, but for the entire company. The second really critical element for our foundational capability is, again, secure, scalable, reliable, and cost-effective private cellular network that covers our plant floors regardless of where it is. And then once you have the connectivity, then you enable the mobility that's needed to access information in the plant. We are putting tremendous effort in cleansing, harmonizing, and organizing our asset data so our colleagues in the field can intuitively access information that they're looking for. So whether it's pulling up maintenance order or the MRO parts required to perform the maintenance, or you want to pull up historian trends to see how the asset's performing, or you want to look up an engineering drawing. All information is available right in their hands when they need it, where they need it. Why? To make informed and intuitive and timely decisions right in the field. So how do we go about doing that? So that's when you go up and we have deployed what's Dow's Connected Worker platform. You've heard a lot here in the ARC conference about the concept. We are calling this thing CFP, or Connected Field Professional, a true mobility platform that runs on a Windows and Android devices. And our environment requires hazard classified devices, so the burden's a lot higher for us to deploy that platform. So once you have that, think about it as a centralized platform to launch applications that enables us to perform our operations and maintenance. So things like digital procedures, rounds, and inspections that are fully digitalized that you can go out and perform in the field. to analytics through manufacturing insights, so things like process automation, health index, to LOPA dashboards that allows us to work safely from a process safety perspective, with an overall intent to reduce unplanned event and run our assets efficiently throughout the plants. Those are the plant-specific implementation. I'll describe the scale of it because it's important, because each one of those things that I just described has to be implemented at every plant within Dow. And then we also have done a site-wide deployment. So think about more like one-time deployment for the entire site, regardless of the plant. So a lot of aggregation of the data for parts availability, for instance, to understand where you are from an MRO perspective, to perform maintenance, and then the mobile maintenance planning as well, also on a mobile platform. We are also uplifting the infrastructure and the way we run our analytical labs and that workflow. And really, really big part of the whole one-time solution required for end-to-end cost management when it comes to contractors. So you have full visibility to the supplier performance and how they're doing, better management of billing, and all the way up to contract compliance, plus making sure that we are eliminating all the contract leakages. So that's a big part of our overall solution to manage how we run operations or maintenance. So everything that I described is no longer a strategy or a concept. If you can see on the right side of the slide, we have many plants within North America, Europe, and Asia Pacific that's being implemented with this capability. And once we have that, we are learning a lot. We are tweaking the information that's needed to continuously enhance the way we manage our assets. Just some numbers. This is end of year last year, but so this is only from our North American implementation, but we have converted and executing significant amount of digital procedures in the field, lots of manufacturing insights, dashboards implemented, the coverage of our wireless across the sites, that's pretty impressive on that private LTE network. And also at the top right, the lot of different data, different data that is coming together for us to then harmonize and then give it to the hands of the people who are using it. Again, the central point of this entire thing is to keeping that employee at the forefront, who is actually using the information to make decisions in the field. So it's always from a perspective of that employee. So where we are right now, real quick, the release 1 of the core build of the entire solution that's implemented. MVP basically is up and running. The core infrastructure, which is really, really critical for us to enable the connectivity and mobility, is up and running. Security is a huge part of our architecture. It's at the forefront. We cannot bypass any of that stuff. So think about securing the network at the periphery, securing the application, hardening the devices and the data. Super critical. It's role-based, so that we can go ahead and turn it on. You switch from a geography to geography. The data privacy rules are different. GDPR comes into play if you go to Europe and things like that. So, but that we have that. And then mobilizing the work execution. You'll hear from the other guests here in a minute, but they're trying to solve similar problem. But we do have that Windows and the Android device, so it's compatible. We have different use cases for depending on what the type of work that you're doing. And then we are continuing to go ahead and focus on enhancing the applications, right? So next generation of value-focused capability and more integration with the operations workflow. All those things that you're seeing on the right, the productivity gains, increased reliability and asset utilization, and reducing the rework is really a big part of it. We have specific use cases about improving the safety through the digital procedures and our data quality, which actually enables the entire solution to work here. The value case is formally reported by Dow, so we can zoom in to see what specific categories that is causing the downtime, and how is this particular solution actually helping to reduce that, and we are going to continue to make sure that it is driving towards the two things that I talked about. One, increasing the capacity and running our asset better. If it's going down, we want to fix it and fix it quicker, and make sure that we are making more product from that asset and selling it to increase the revenue. And then significantly improve the way we work through the productivity improvement is really much bigger part of the value case. So that's my presentation, a quick journey for the Dow's digital effort and how it relates to this topic.
Hi, my name is Nicholas Hofelt. I'm the Senior Reliability Engineer at Itafos Conda, located in Soda Springs, Idaho. I was a primary team member involved with the implementation of asset care to support the long-term sustainability of our fertilizer manufacturing facility. Our facility is a vertically integrated phosphate fertilizer business that produces a wide variety of products, including superphosphoric acid, monoammonium phosphate, and various other specialty fertilizer products for the North American market. Our site has a long history. It was actually built on a 250-acre parcel of farmland in 1964, and it's been in near continuous operation ever since. Our site, along with its 54-year operating history at the time, was acquired by Itafos in January of 2018. Currently, we use Bentley's APM AssetWise software to develop, deploy, and maintain our tablet-based asset care program for our site. So today, I'm going to kind of share our journey with you and show you how we use this asset care software to support our safety, process safety, environmental stewardship, and reliability goals. That was last week. So, as you can imagine, a site with a 54-year operating history has a lot of competing priorities, ideas, and methods for care of the assets and collection of maintenance and reliability data. This data, if collected at all prior to the implementation of the AssetWise software, was collected in electronic spreadsheets, other electronic formats, or paper check sheets that were frequently lost, not attached to work orders, and were stored both on and off the site. This data is needed to be collected so that for things like insurance and safety audits and recertification of our VPP star status, we have to gather this information to provide examples of performing required checks and completing follow-up on actionable items. In the small mountain community where our site is located, wow, I didn't do that. Well, in any case, in the small mountain community where our site is located, sustainability means more than just hitting production numbers. It means good paying jobs. It means keeping people safe, protecting the environment, and being a good neighbor and being involved in the local communities where we live, work, and do business in. Our scope of the project was to develop a continuous improvement process that would develop asset care plans that would provide needed reliability and maintenance data, was easily accessible, quick to deploy, and would be consistent across all areas in our plant. There we go. With over 9,000 active maintainable assets, we recognize that our site's long-term sustainability was intimately linked with our ability to effectively and efficiently maintain these assets. So consequently, we identified asset care as a key pillar in our reliability program. But what would a real asset care program look like, and how were we going to get there? So our strategy to implement the program was essentially just to hit the ground running. We wanted a rapid implementation. We wanted to avoid analysis paralysis. And we wanted to have the maximum impact to the site. In addition, we wanted to build on our history because you can't just scrap 54 years of operating knowledge on day one. So it was the recognition that this wasn't just an asset care program, but it was a culture change, and we had to have everybody on board. So we took a ground-up approach. We targeted the tasks of our operators and maintainers. We didn't start from scratch, but we had to ask ourselves some questions about where we were and how we had gotten there. What assets were we looking at? Who was looking at them? What's the frequency we're looking at them? And are we looking at the right things at the right time? By reviewing our current methods, we gave ourselves an opportunity to ask these questions, and we made an impact immediately as we transitioned our paper check sheets to electronic tablet-based check sheets. By using customizable templates, we developed a consistent framework for the creation of these routes and ensuring that similar pieces of equipment were being looked at the same way all the way across our site. The indicators developed for these check sheets would now prompt action from our collectors and maintainers when put into an alarm state. And this gives some insight into what normal should look like versus what we were seeing. And this was something that your previous collection methods lacked. It wasn't perfect, but our strategy allowed for that. Analysis and optimization would be our keys to continuous improvement. So, what did we analyze? There we go. All right. Having a little trouble there with the computer. We needed to spend our time efficiently, so our first task was to identify high critical assets, including safety critical assets, so that we could provide direction for the development and optimization of our asset care plans. By spending the time to perform asset prioritization analysis, we were able to generate a roadmap that would direct further improvements to our reliability program. And now with a list of prioritized assets and assets that now had electronic check sheets in hand, we could focus on assets that either had no asset care plans in place or were high critical or safety critical to the site. We currently continue to improve our asset care plans through a combination of maintenance task analysis and current practice reviews, and this helps us identify our assets' current operating context, reasonably likely functional failures, and their potential effects. Using AssetWise, we fully documented this information into a single location that's accessible to all stakeholders. And this understanding of these three key items is a key requirement to develop appropriate asset care plans to monitor for and prevent functional failures of our assets. So now that we've set up basic operator and maintainer routes, how did we leverage that information to produce meaningful tasks that would assist us on our quest for sustainability? As our operators and maintainers perform their daily routes, they select indicator states for each collection point. If a defect is observed, various actions could be recommended and taken based on the severity of the defect. Additionally, if a defect was found, we set up immediate email notifications so that we could send it out to the people who need to know about it without imposing on our operator or maintainers daily responsibilities. So now it became easy to monitor our assets for alarms, follow-up, and to capture remaining maintenance history. We also connected this system to our CMMS, Computerized Maintenance Management System, to capture those defects and seamlessly integrated it into our work management process. That way we get the necessary information to the shop floor so that required maintenance can be planned, scheduled, and completed before functional failure occurs. And this ease of access and availability of data led us to change this from just a purely asset performance management tool to leveraging the capabilities of the system to make it easier to comply with site requirements for PHA-identified safety critical systems and devices, with regulatory compliance, and even to gather temporary information when remote monitoring or data logging was not feasible or possible while we troubleshooted process or equipment issues. And in these types of situations, the flexibility to do that became critical. So how did we do? So to develop effective asset management strategies, we developed a better understanding of our assets by documenting the current operating context, using various reliability studies to optimize our asset care plans, creating a consistent framework for monitoring and maintaining our assets, and we've developed indicator and alarm states to identify potential issues and correct them before they become functional failures. To date, we've analyzed and ensured that over 95% of our highest criticality assets have implemented asset care plans in place. Additionally, we leverage the capabilities of the software to provide critical information to various groups in the plant in a much more efficient manner by providing our immediate email notifications to individuals or departments on readings taken, monitoring equipment for abnormalities and maintenance history, and we put that in a single digital environment, and we provide quick and easy access to reports and completed routes. And by doing this, we've reduced the time frame for collecting data for review and maintenance information from potentially days to just minutes. And finally, the connection to our CMMS prevents us from having to log into a separate system to initiate action against these abnormalities that are found. This transfers into our work management system in less than a minute, and it actually ends up saving about 4 minutes of time per issue identified to generate a work request and get it into the right hands. So what I want to, 98% check sheet completion. We have 220 active APM users with about 450 checks per week, resulting in 23,000 annual checks that now have digital verification. So some tips and tricks for implementing a digital asset care solution from us. And these are our experiences, yours may differ. Number 10, if you're looking for tips and tricks to implement a digital asset care solution, you probably already have management approval, but what we're actually talking about here is management understanding. Not everyone has to be an asset care specialist, reliability engineer, or even understand what IT, OT, IIoT, big data analytics, all of this stuff that you guys are here for, they don't necessarily have to understand that. But some basic knowledge and terminology understanding goes a long way to get the support and the horsepower that you need to implement this type of program. I was fortunate because I have a site director who understands what a PF curve is and will ask questions about operating context and functional failures. Additionally, I have a maintenance manager who understands reliability, and that helps a bunch to be able to explain the difficulties and goals with this type of program. So if you don't have those two guys, spend a little bit of time, distill some basic terminology and knowledge, and present it to your leadership before launch. Number 9, you have to sell the program, you have to be excited, and you have to be positive. This is really important because you're implementing something that is part of a culture change. It takes time and patience. You will get frustrated, and things may take an exorbitant amount of time sometimes, but you have to remain consistently positive. It's going to be different than what we've always done before, and the biggest question is going to be why. So sell the information to the guys on the ground and sell them the benefits of using the program, the simplification, efficiency, and the promotion of ownership. This was our tactic, starting with the boots on the ground, the tasks of our operators and maintainers. Our equipment operators are around or look at almost every single piece of equipment every day. So that represents a lot of eyes and ears that our reliability and maintenance teams rely on to give them a heads up on issues. So they're probably already performing some checks, either by design or because they're good operators. And this leads us to using what you have. You don't have to start from scratch. Find out what checks your guys are doing. If they're anything like us, they're using a Word document, an Excel spreadsheet, or a paper check sheet somewhere in their control room to do their daily checks. The other possibility is that it's tribal knowledge, and without being documented, it'll eventually get lost. So this is where your review of your indicators and states starts, you can have those good conversations with your operators and record that information so it isn't lost. And number 6, this ties in with number 7. Measure the right things. So we still have to measure the right things. This is where the optimization of your routes start. Look for things that don't need to be checked, checks that don't bring value, or when asked, why are we looking at this? There isn't a clear answer other than we've always looked at this. And you want to migrate towards things that there are clear failure modes. And number 5, tie the checks to actionable acknowledgements. If we're looking at something, we should know what good and bad is. If we don't have clear criteria or something that's actionable, we really need to question if it's the right thing. See number 6. Get operations and maintenance involved. Know the importance of your checks and measurements. And this is where your states and alarms now come into play. Set your alarms, work with your process group and your operations to find out what normal is, and then to determine when maintenance starts to get nervous or get clear guidelines from a manufacturer. Ask operations if you're at a high or a low alarm state, what do you do? And then establish clear criteria on what to do based on the measurements that we do take. Number 4, at the development stage of your program, we say have an implementer. Your implementer will sit down with your operations maintenance groups and start to develop your asset care plans. So we quickly identified that just adding this task onto the responsibilities of a single person was a poor strategy. Our implementer was invaluable in gathering up check sheets from each area and identifying non-documented checks, developing training, and incorporating feedback from operators and maintainers into the development of the routes. Additionally, at the start, there was a lot of troubleshooting, QA testing, integration testing, and conversations with our provider that required a lot of time and effort, and that was all taken care of by our implementer. All right, number 3, be friends with your IT group and your provider. One quick way to lose credibility is when a piece of software or hardware doesn't work. Your IT group is your best friend at this point. Thank you. Involve them early, give them time to get their hands on the software, on the program, on the hardware, and get their commitment in resolving issues quickly. When you have people collecting data every day in a deployment in a site with multiple locations, any type of disruption to that causes a loss in credibility. Excuses for not completing their routes or putting in the actions will start to crop up. The hardware doesn't work. The routes are not on the tablets. These are things that I've heard, and sadly, they were valid in a lot of cases. In addition, with your provider, if you have trouble with the solution provider, it needs to be addressed. Their support is key, but so is urgency. Issues have to be resolved quickly. Here's also another place where your implementer is key. They can communicate and spend the required amount of time following up and resolving those issues. You have to have high expectations from your IT group and your solutions provider, and then be thankful when they resolve issues quickly. Here's the second way you lose credibility. If you find problems, you have to fix them. So you've just asked your operators and maintainers to go look at a bunch of stuff a lot closer than before. If they find an issue and report it, you need to fix it. And this goes for problems with your actual indicators or routes, or a defect that's identified during a collection route. This means that if stuff was put into a work order from a collection route, or an indicator or state doesn't make sense or is wrong, you have to strive to correct it before the next time the route is taken, if at all possible. You're trying to build confidence in a system that we're using, and we're using the system to solve problems. And if we leave an indicator in an alarm state until it fails, tells the guys at your plant that this isn't anything different than anything that's come before. So in order to succeed, we have to do better. And the last one, you have to be available. You have to communicate and respond to issues quickly and be willing to go the extra mile to instruct people on how to do things, walk them through troubleshooting, log into their system if you're able to do that, and walk them through their issue. Go to the morning pre-shifts, talk through common issues, solicit feedback, and ask for their help. Be willing to explain the reason we're moving in the direction that we are and share your successes with them. It goes a long way to take a phone call, walk somebody through an issue, and then thank them for taking the time to get that issue resolved. So for this project, we accomplished a fusion of both historical learnings and industry-leading best practices in the care of our assets. Even with the high complexity of our assets through changes, additions, modifications, and upgrades, we're continuing to develop the consistency and care of our assets in a real and practical way, and it's enabling our site to operate in a more and more sustainable manner. We've leveraged this consistent framework to integrate our people, our processes, and our reliability analysis to improve the longevity of our plant, maintain our freedom to operate, support our corporate values for stewardship of the environment, as well as sustainability for the good of our site and our community that we live and work in. And it helps support our goal of feeding the world. Thanks.
Good morning. My name is Mark Holden. Just a little bit about me, a little bit about Indorama. I am a chemical engineer, spent most of my time in manufacturing, process engineer, process control engineering, and now helping lead the global digital manufacturing for Indorama Ventures. Also a dad of 3 and a little grandbaby that was just born who just so happens to be at SeaWorld today, so I hope to catch them later. The company I work for is called Indorama Ventures. Indorama is a growing company, now about $15 billion in revenue, 35 countries, 140 manufacturing sites. You would know us from our products in water bottles, PET, plastics. 1 in 5 bottles globally is produced from polymers from Indorama. 1 in 2 premium baby diapers are made from fibers from Indorama. 1 in 4 airbags from our yarns, and we are the #1 surfactants producer in the Americas. So just quickly, our value stream is centered around PET. We do have, all the way from shale gas ethane to produce ethylene to ethylene glycol to make PET, as well as paraxylene to PTA, and then the end products of packaging. Recycling, which is a huge focus for us around sustainability, and in fibers we use polyester, but also nylon, rayon, polypropylene, polyethylene for the 3 verticals we have in fibers. And so thank you. Many of you in the room perhaps are customers. We appreciate focusing on the customers and helping us grow. What I'd like to talk about today is around APM. What is and how does it benefit us? We really use it focusing on 2 primary focus points, and one is around reliability. And one way to look at reliability around this, from monitoring to prediction, we do have already deployed, and for decades have deployed, condition-based monitoring sensors. And we have used the APM focus to help build an extra layer of understanding with digital twins. So we're taking first principle physics-based models to indicate where we are versus where we should be, and generating some actions and alerts from that. And then at a very customized level, building some machine learning solutions to help identify patterns and anomaly detection and providing alerts for that. So for the reliability, building a model that indicates how far you've drifted away from normal, which would be the top line, and then the bottom section there is Paretoing out the causes associated with that. And so we're using Honeywell's APM software to help us do that in these applications. And also with the tool, it allows very easily for you to capture how faults happen and bring that data in with a history of alerts and what was actively causing an issue at this time, and then also when was the last time something alarmed in this fault pattern is a helpful way to diagnose, and capture knowledge. So that's from a reliability standpoint, and from a performance modeling standpoint, this is just one example we've used to build a digital twin. Digital twin terms used very loosely. Broadly, what we're describing here is the mathematical representation of a physical asset. And in this case, we have a problem here. We're using too much, in this case, of nitrogen is what we're actually consuming here. But there's a problem, and it's really hard looking at this blue line to predict where the problem is. And if you use statistical process control, you still can't find the problem. What the digital twin enables you to do is layer in some visibility to where you should be. So if I were to build the twin, it could tell you the yellow line's where I should be. And now you can easily begin to see where you departed from normal in this case. And if you monitor the gap between normal and where you actually are, you can then begin to set alerts that help guide you to making solutions. So the red line is just the delta between those two, and whenever the red line gets above some statistical significant variable, we send an alert. And so if you look at the black line, you can see when the black line goes up, there's an alert. You can see where the problem started, and then about midway when it was corrected. But it's completely invisible unless you have the twin. And so now we're using this tool to help us send alerts to people in the area that indicate, hey, you should do something. And where before we just couldn't tell. We'd come to the morning meeting, you're using nitrogen. Everybody go check your nitrogen meter. And so now this helps, give a very specific guidance to improve that. This is what it looks like in the Honeywell tool. So how to be successful, I can speak to both ends, how to be not successful and how to be successful. So definitely start with the problem. Don't deploy technology. You will get easy adoption if you walk in and say, please, we want to teach you about machine learning and artificial intelligence and digital twins, and everybody's super excited, and they run to the room and they learn about it, and then they leave the room, they might deploy a model. What we're talking about is how do you keep them involved, and how do you keep them engaged? And it really comes back to, are you solving a problem that's meaningful? And like the nitrogen example, that returns several $1,000s every month versus where we were, and people are excited about keeping it and sustaining it. Some of the other models we've built, we've deployed this solution at 10 sites globally, and some sites aren't using it, and some sites are using it, and it really has to do with, are you solving a real problem that matters to people? The second thing we learned is, and we did an analysis in 2021 of all the projects, and they really fell into three buckets. We had projects that were contributing value and were successful. We had projects that were technically successful, but were not contributing value. And we had projects that were just not successful at all. I mean, we didn't have the data, we weren't successful. And we went back and analyzed, why is that? The one that frustrates us the most is, we build a model, it works, but nobody uses it. That's very frustrating. And we sort of come up with these three buckets that really help prioritize and make sure that you can get adoption, long-term adoption. One is you have to have leadership commitment. There will be problems. You really need the leader to say, I want it, I need it, please make this happen. The other thing we noticed is, especially with data models, is you have to have data. And our plants are like many of yours, built in the 50s, 60s, and 70s. I heard someone say yesterday, like a classic rock station. The problem with data is real. We have some data, but really the amount of data you need to do analytics, you may not have. And so that can stop you from being successful. And the last thing we found is, don't expect someone who already has a full-time job and already has a project that they're managing to come in and learn how to do machine learning or AI, right? You're going to need some time to work. You got to dedicate some resources to make this happen so that they can learn it, believe it, and adopt it. Also, a non-threatening learning environment is helpful. Focusing on people is what sustains the capability. We developed something called the Digital Academy, and our Digital Academy helps teach people what are basics around digital transformation, but specifically around APM, we could not have the live training session. So we deployed all this through COVID. We were actually getting started right as we left ARC in 2020, February 2020. So we've been on the journey since then, and we couldn't have the in-person training, and actually COVID actually helped because through MS Teams we recorded the training sessions, and so now those are stored on our company intranet, and when someone comes new, we say, please go watch the training, and they get the same training that everybody got, online. So that actually helped us. Having a team to support the people at the sites when they get stuck on something like machine learning or analytics is vital, and supporting the teams, from a regional perspective. Also, just to give credit to to Honeywell, our technical partner, have been fantastic partners to help lead us through and learn some of the tools. And so we really appreciate, not only their knowledge, but also the programmatic deployment and our internal network of collaboration. So lastly, just quickly, it does help to have some guidance and communicate. So we have a daily review of alerts that are sent via email. We actually still manage a lot of those, and so working through that. But weekly, we do summarize the alerts and send action points to the specific the remote support person does that and sends specific action points. Monthly, we track the savings, and quarterly, we have a review with leadership and with our partners. So that's what I have to say. Thank you.
So my name is Alexandre Cassenio. I'm a rotating equipment engineer working for Total Energies, and we're here to present you with, together with Matthias, our remote monitoring initiative that now is nearly 10 years old within our organization. So just to start, a few words on Total Energies. So we are an integrated multi-energy company with 100,000 people around 130 countries in the world. We are a historical oil and gas company, switching from oil and gas to a multi-energy company. So we have a slide video to show you.
Energy is life. We all need it, and it's a source of progress. So today, to contribute to the sustainable development of the planet facing the climate challenge, we are moving forward together towards new energies. Energy is reinventing itself, and this energy journey is ours. Our ambition is to be a world-class player in the energy transition. That is why Total is transforming and becoming Total Energies.
So just a quick overview of Total Energies perimeter. So as you can see, we are integrated. So we are producers, transformers, and distributors of energies. To be frankly speaking, we are more in the red part currently, or the dark blue part, so oil and gas, LNG, but we are switching currently to a more lighter blue, and who knows, in the next future will be greener and greener. The idea and the ambition is to become carbon neutral by 2050, and with a milestone in 2030 to reduce by 40% of our carbon footprint impact. And to support this transition, we need to focus on our strengths today, our operational excellence. And that's why we are talking here about our initiative in the upstream part of Total Energies. So our remote monitoring center is called a Remote Assistance Intervention and Diagnostics, so-called RAID, and where it's come from. It's coming from the early 2010s, where we had a lot of projects coming online, mainly in West Africa. We had a growing fleet, and we had to face an increased number of failures across our fleets. And last, in 2009, we had a major accident offshore with severe consequence. A turbo compressor got fired, and we had to shut down hopefully no injuries and no fatalities, but we had to shut down the platform for 6 months. So I guess you understand the consequences. So we went through all these failures, and we figured out mainly that half of those could have been anticipated if we had a good condition-based maintenance and a proper remote monitoring follow-up. Basically, 80% of our centrifugal compressor failures could have been avoided, and 30% of our gas turbine failures. And I'm giving the hand to Matthias, our SME in this subject.
Good afternoon. Are you okay? Thank you for still being here right now. Do you know the difference between a smart man and a wise man or woman? Smart man fix the problem that the wise man has avoided. We are trying to get into this direction. We are in the monitoring center using the smart signal software to anticipate our failure, trying to get wiser and wiser. We are here to talk about data. What is data for us? At least data for me, who is a mechanical engineering with a maintenance career, starting on the oil and gas plant, is the data directly coming from the machines. It's a real data. Pressures, temperatures, flows, vibrations. Those data comes from our production plants through their sensors, through the industrial network, and is analyzed with a smart signal. And smart signal is a software which you should already know, I hope for you. At least those kind of analytics in order to detect and to predict or anticipate the failure. This data comes through the internet to our remote monitoring center located in southern France, in Pau. I invite you to come and visit us if you have the opportunity, at least to visit France, especially during the fall. This data is analyzed with our colleagues in this center. So we are 4 analysts in this center to monitor the data from all our fleet, roughly 800 equipment. And after the analysis of this data, we communicate to our sites, generally the production plants, in order to implement or to perform the corrective action before the problem occurs. The way we do that, and we choose to do that, so about a decade ago, is to centralize the monitoring. Some of you know that either we externalize the monitoring or we keep this monitoring in-house. And this is the strategy we decided to employ within Total Energy, is keep this monitoring in-house in order to analyze the entire process, to correlate similar issues around our fleet, because we are using different manufacturers, different operating conditions, and as well strengthen the communication between headquarters and our affiliates. Communication is a very important issue. One of our colleagues previously said that. He's true. And capitalize the internal competencies so that all those competencies remains in our company. We are able as well to analyze and change or make our maintenance philosophy evolve from the condition-based maintenance to the planned maintenance, preventive, predictive, whatever you want, but at least we use the data and the history we have on our machines in order to adapt the machine and the site operation to the best maintenance philosophy. And of course, because we all do this in the business, we reduce the flaring, we reduce our impact environmentally. That is to say, we maximize and we optimize the oil production. I can say that because we are here between industrials, but technically we prefer to say that we reduce the flaring and we optimize the operation. But you know, the world needs oil and energy, and we are here to do this and to answer the demand. So total energy upstream, meaning the production of the crude oil to the refineries, we are monitoring assets since 2013. At that time, Smart Signal was not yet acquired by General Electric Digital. And we monitor equipment around 11 affiliates, 11 countries, let's say, 360 shaft lines, roughly 300, it gives roughly through the Smart Signal, roughly 36,000 alerts a year. That's all of the alerts that we monitor in our remote monitoring center. We analyze them and we, let's say, sort the real alerts through all the false positive or real positive that we have. And it gives us roughly 500 catch, meaning real potential issues that we have avoided throughout the year, throughout our 11 affiliates. In order the presentation to be a little bit more technical so that you don't fall asleep too early, I will, let's say, give you a few of real cases that we have raised, let's say, a few years ago. But before that, keep in mind that our failures generally occurs on the equipment, generally mechanical issues, bearing problem, for example, dry gas seal issues, or instrumentation failures. Roughly half of our failures come from instrument failures. So maybe we have an action to take related to our instrument provider. However, the instrumentation is very, very important for us because if we don't have this instrumentation, we don't have the data. And without the data, in France, we are blind. So an example of key cache that I would like you to understand so that you, let's say, can feel how important the remote monitoring is for our industry. And I have selected a few examples that doesn't necessarily require a high level of technicity or to be very, let's say, competent in the machine so that everybody can potentially understand what we are talking about. Compared to our colleagues previously who used the Honeywell software, we use Smart Signal, and finally, the trends, it's just a matter of colors, but the philosophy is roughly the same. For us, the blue line is the real-time value, the one which is actually drifting. And the green line, which is the most important in the remote monitoring, is the anticipated value. So this is the value which is calculated, processed by Smart Signal, so that we can compare the real-time value with the historical value. Because as he said, and he's totally right, without this value, we cannot, let's say, we cannot see directly if there is a problem or not. In this one, we saw a deviation on the blue line. This is a vibration of a compressor. This compressor produced 50% of a site which produced 100,000 barrels of oil equivalent per day. So you know the price of the oil today. You make your own calculation because I cannot. But we all know that the figure is quite important, especially after 6 months of shutdown. And it led to 10 days of unavailability. With the anticipation of this failure, we could reduce this downtime to 3 days. And it makes us save a consequent amount of money. With a very simple analysis of the trend, the vibration increase, we anticipate the shutdown of the machine before the bearing fails. We replace the compressor. It's very quickly done. It's very simple. And we save a lot of money on that one. We save a lot of money because we save a lot of time. And there is a direct link between the two in the oil and gas. This one is another example. This is an axial compressor of a gas turbine. So GE Digital is our partner for at least a decade, but GE Aero, provider of this turbine, it's another story. This one is very interesting. You see, I'm sorry that I cannot directly show you, but you understand what I mean. The blue line and raise an alarm, but the level of vibration is widely below the, let's say, the actual shutdown limit on the site, meaning that whatever the technical personnel on shore, whatever the round, let's say the operation, we cannot see that something is happening on the machine, but we can. We know that the turbine is typically, let's say, facing some issues on the blades. We recommend an inspection of this turbine so that they can plan the shutdown of the machine, inform the customer, in this present case, that the production of gas will be reduced. We inspect the machine, we confirm there is a technical issue on the machine, and then we can plan the replacement. So on this picture, you can see two periods of shutdown, one for inspection, one for replacement of the engine. And afterward, on the right side of the picture, the machine restarts with normal operating parameters. At least this is a very good example of anticipation of a failure. If the failure is not anticipated, we don't have the material on board, we have problem of customs, it will take months, probably or eventually problems of weather, it can escalate and we don't know where is the limit. So this is real issues that we are facing, let's say not every day, but with a significant frequency. And one last, this one is interesting as well because it's very obvious to understand. When there is no green, it means that the machine is stopped. So the machine on the left side is running normally, there is a spike, the machine is stopped, and when the restart, the blue line, I remind, is the actual value, is much more higher than usual. We, let's say, analyze all the data with all the correlated parameter. We understand it's coming from a ventilation issue on the machine, which was the gas turbine. So considering our experience around the fleet, we know it's generally a problem of damper. So we recommend our operators to go and check the dampers, see if the ventilation is okay. That's what they do. They close the damper and the temperature comes back to normal. So this is typical example and real example of the relation between the headquarters. When we are working, we analyze the data from, let's say, thousands of miles away from our operation. And with a good communication with our sites, we can perform this kind of anticipation and avoid problem. So that's why we are trying to get wiser and anticipate our failure before they happen. Otherwise, as we are smart, we know how to fix them. But the better if we can avoid. So thank you for being here and listening to me.
So we have some panelists join on stage as well. Speakers got a chance to introduce themselves. Can panelists that just joined please introduce yourself as well?
Sure. My name is Thomas Lovis. I'm the product manager at GE Digital for our APM reliability and smart signal software.
Brian Flett from Bentley Systems, also in the product management, responsible for asset performance management and our digital twin solutions.
Hemant Pandit, I work for Honeywell in Houston office. I'm a senior director, and my passion is operationalizing digitalization for my clients. Thank you, ARC, for this opportunity, and I'm looking forward to a discussion here.
So we can, if audience members have any questions, they can raise your hand, and my colleague Dan would go to them. And can you please turn that on?
How about now?
Yeah.
Mike Richards, J&J, thank you for your presentation. I have, I guess, one question. I saw a lot of successes, and one of the challenges that I think I face is that interfaces with other systems. I think, Malik, you showed that would be one of the biggest challenges. Nicholas, you had shown some connections to CMS, MMS systems. How do you overcome those challenges? I mean, I know we need leadership support, but in a siloed organization or one department's goals and objectives may not be aligned with others. How do you overcome those challenges?
Yeah, that's a big problem, and the way we are doing it is really kind of taking a top-down view. So I think a lot of people talk about the Purdue model, but like in ISA stack and what are the interfaces that are really, really required, right, from our end-to-end solution. So whether you're going from if you're trying to solve an agile fulfill operations problem or a B2B problem, or if you want to connect I talked about the one automation for contractor management, for instance, right? Contract to pay. You're talking about a lot of different things that she needs to integrate. So once you identify that, you have to work. We have been working with the appropriate functional leadership, right, at the top level, say, hey, this is important, we need to do it. We need commitments for the data. I talked about the data hub, because a lot of cleansing is required to put the data in the right place. And then our tech centers define the appropriate technology. So I think we talked about the fact that you define the business problem first, get a buy-in, and then have the technology in place to say, how do you integrate it? In our case, we are a 125-year-old company. We have a lot of point-to-point interfaces that are applicable. We are using the service bus and that kind of technology, right, to make the interfaces to work seamlessly. But it's really critical. I would say leadership, commitment, get the data in the right place, make sure that you have the ownership of the data objects defined as to who's going to maintain that. And then the technology piece is really the most simplest things to solve ultimately, because it's available right now.
So I'll speak to that a little bit too. And ours is a little bit different because we're not necessarily talking about, making sure that everybody's data is together, but it was more about getting different sandboxes to play together nicely. And when you own a particular sandbox, in our example, our CMMS system, the owners of that particular area, that silo, a lot of times they don't want anybody else playing in their area. And so it becomes about what the value is for them for you to be able to integrate with their system. And that was the challenge for us, is how do we identify what kind of value you're going to get out of operators taking routes out in the plant, putting in information, and then pushing it into your CMMS and working through that work management process at our site. And it really became about identifying what the value was at each step and being able to properly communicate that to those various groups that you had to interface with, and making it something that they go, you know what, that makes a lot of sense. We'd like to reduce duplicate work orders, and that would help us manage our backlog. And that was where we had those good conversations with the various departments. For example, our planning and scheduling department, we had to interface with them to be able to use our tablet-based operator rounds to push those work orders. And we had to explain to them, why is this important to you, and why would you want to allow us to make that interface? And so it was more of a people connection for us than anything else. And it worked out pretty well. And we have more things planned to try to interface with more groups and get more of that data into a centralized location.
Yeah, I think from a vendor perspective, we certainly heard the message in the keynote this morning, and I think as vendors we can all agree, the days of a single vendor and a single solution from one vendor are over. I think we all know that, and we're very much working together to try and create standards, to create interoperability, to make sure that our systems can talk to each other. So certainly the message is heard, and we're working toward that.
Yeah, I think I'll also give a different perspective. Yes, I think from a technology perspective, we had to make sure our technologies integrate. That gets into API connectivity, so on and so forth. But I think the other, maybe sometimes bigger challenge is once you really integrate, how do you use that information? So when I think Preet put out the first challenge that talked about integration of systems, I think the bigger challenge coming up is going to be, do you have the organizational structure, the processes to make use of that? And that gets into the whole technology adoption and so on. So I look at integration from those two perspectives, the technology piece and the actual deployment piece of it.
And one other thing I would say is, about the type of data that you're using and making sure you have the right data at the right time, with the right information coming from it too, whether it's historian, CMMS, and making sure that, your asset information is being brought over and talking with each other. That's, another really important piece that we got to make sure that it's set up correctly.
Yeah, and I would quickly like to add as well that we know this is a known problem. All end users always appear as the biggest challenge, and we constantly know that technology providers are working on that. And in our future, it's going to become even more critical because when we are talking about connected worker technologies, when we want to use augmented reality, we want to make sure that if we are talking about augmented reality, when somebody is wearing a heads-up display or a smart camera, they want to have the right data at right time. So everything needs to be integrated with one another if we want to make the connected worker a reality. Any other question?
Hey, good morning. Great presentation. Mark Susich with Emerson. My question's directed toward Nicholas, but I welcome feedback from everybody up there. During the presentation, anomaly and defect were interchanged. And I'm curious, could you elaborate on your workflow when anomaly truly becomes an actual anomaly and meets the definition of a defect? Do you have defined criteria and algorithms that are flagging that so it's automated going to your CMS, or SMEs looking at that data, making a decision based on plant equipment behavior, or a hybrid model?
So we don't have anything as sophisticated as any type of analysis that automatically determines whether it has changed from an anomaly to a defect. However, we've set up our indicators in states to identify varying different levels of criticality for the indicators that you put into place. And in certain cases where it would require somebody to maybe look at it closer to really determine what's happening, we use the immediate email notifications. It'll go to people like our lubrication specialists, our vibration techs, our mechanical integrity inspectors, or our process engineering group, and it'll flag those things as either something that they need to go take a look at sooner, or something that they need to look at closer to identify that. So I think our digital transformation journey is kind of at the beginning stages of what we would like to accomplish with it. So things like machine learning and AI, those are in our future, but we're not quite there yet.
Do you mind if I complement a little bit this answer? I understand your question because finally, we started this remote monitoring things with data management and stuff about 10 years ago. Myself, I was working as in charge of maintenance on a remote platform in Myanmar, 12,000 kilometers from Paris, actually. And I first received an alert, so an anomaly. And I say, what the hell have they seen in Paris that I haven't seen myself from 100 meters? And it was actually the delta P across filters that was rising. So it was true. So when now I'm working on the other side of the barrier, I know that some sites receive the anomaly, generally discard the anomaly, and then they get to the failure. They do it twice, sometimes 3 times, and after a shutdown of a couple of months when they have to justify why they have discarded the alerts from the headquarters, they never do it a 4th time. So we generally, years ago, regularly reach the level of failure, but less and less right now. Thankfully, mind changed and the data is more and more accepted, because before it was more than a big brother thing, But now things have changed, at least from our point of view between operation and headquarters.
Maybe just to complement what is different is that it's SME who are doing that kind of analysis inside. So people are talking with people, and most of them, as Matthias said, they've been at their position before. So they know what their daily job, they know they have their day-to-day activity, so they are not looking after all the data and all the threshold. So when they see an alert, they raise it a case, they provide some recommendation, but it's not an automated, recognition pattern. It's SME who we rely on people for that.
That's why we need to be friends with everyone, not only with us.
Agreed.
Okay, yeah. Sami Koskinen with BMAX. First, thank you for great presentations. I think I have just a practical question. You all want to digitalize your data and to be able to then maintain your operation, you probably use a service providers for your plant maintenance, right? Do you allow them to access your systems and provide the data directly to your systems, or how do you manage your service providers?
Yeah, I can answer at least partially to this question. We are happy with the Smart Signal because with this software, we have access to everything. It's not a black box. I mean, the software is provided, the algorithm is working on its side, but the data is within Total Energies on premises. So far, we are reluctant to have this data on the clouds and share this operational data. All the operational data from the oil and gas producer and all energies or any company is the asset of the company. If we lose this data, we lose partially a lot of our history and the way we operate. We don't want this to happen. So the data is on our servers. And with the Smart Signal and Sentinel Suite, at least we have access. We manage the users, we manage the data, we can erase whatever we want, we can customize the history we want to keep into the servers. So the data remains within our server. Even if the server may be managed by Amazon or whatever other, let's say, data center management. But the data itself and the content of the data, which is used by the software, is still ours. And the philosophy today of Total Energy is to have this data internally on our servers, and we are still reluctant to have those data on clouds. Even if we are definitely, we trust our providers that this data won't leak anywhere, but who knows?
And as well with the Smart Signal, this software is used at headquarters, but the access is granted for everyone everywhere. And with regards to maintenance contracts, the site or affiliate, they are managing their contract themselves. So they are using the data and they are liaising with the contract on site because all affiliates have different contracts or methods or strategy with regards to maintenance. So they're using it and thereafter they launch work orders or with directly their contracts.
Anybody else would like to add anything? Related question to technology providers. Again, we talk about security and data safety, how secure is our data, As Matthias and Alex said, they are not that comfortable yet to putting on their data on cloud, and theirs is on-prem. Do you see that issue coming up do you hear the same issue from other end users? Do you see preference changing?
Yeah, so definitely we see different approaches in different industries, and we definitely see change. So there's no question from a vendor perspective, we can develop much more quickly, we can get changes out there much more quickly if everything is cloud-based, and more and more requirements are coming to collaborate between the owners of the asset and their maintenance providers and the various other service providers. So there's a whole bunch of efficiencies that can come from the cloud approach, but obviously there's a bunch of risks as well. And so often we see kind of a hybrid cloud approach where certain information that the organizations are comfortable sharing may be cloud-based and may be accessible across multiple organizations. Well, other pieces of information that may be more, where security is more of a concern, may be maintained on premises, and you have this hybrid model, and that seems to be where we're seeing the industry going. I don't know what your experience is.
And I say also, based on the country that you're working in as well too, government regulations as well, some of them will not allow data outside the country. And if you don't have a point of presence, with AWS or Azure and stuff like that, then you really have to stay with the on-premise deployment option. But, we've seen a lot more on the power generation side, moving towards cloud information and having it hosted by our providers as well too. But on the oil and gas, some of them are transitioning to there, mining, aviation, all different customers that work with. It really depends on government regulations, the countries that they're in, plus, where they are in their data journey.
Yeah, I guess just to add to what you just said. I think in our case, what we see is we do have clients who are where we host these, especially APM type solution on the cloud. But you also have to respect some of the region-specific data privacy type rules and guidelines. So we do have regional solutions in that case. So I think from a technology perspective, we see that being a trend, but cautious. I think customers, and I think on the legality side of things, you just go through a whole bunch of discussions on ownership of data, IP, and so on. So you just have to walk through those spaces. Yeah.
Do we have more questions in the audience?
Hi, Rafael, ARC Advisory Group. This is the examples that Total Energy showed of the catches appeared mostly to be a step function increase in some parameter versus a very gradual increase. Did you have any catches that were of a gradual nature? And just general for the speakers, are there different approaches needed, step function versus gradual?
Actually, you have a lot of examples, a lot, but we had only 15 minutes to present. Yeah, we have a lot of gradual. We have say examples where we are able to monitor some deviation lasting for at least a year with very slow degradation, slow but sure. Example would be degradation of a dry gas seal on centrifugal compressor, where you can see deviation of a primary vent pressure, which is measured in millibar, so should be PSI, I guess, very slowly, but we know that the machine is degrading. We know it perfectly. We have example of which are a little bit less fancy, I would say, hydraulic oil filters, delta P, increasing as well. This is typically slow increase, but which obviously lead to some problem. But technically speaking, on the machine, there is no emergency shutdown coming from this delta P, for example, so there is nothing to worry about very quickly. Vibration issues sometimes occurred very quickly. We were able to catch this one before trip happens, luckily, within a few hours. So we have a lot of examples of slow degradation. But I selected those examples because generally with the step increase, we remain below the alert level or the shutdown level of the machine, even below the alarm level. So it means that the operator is not aware that there is a step increase. And the step increase generally is not looking very critical. That's why I chose this example from my catch library, I would say. But we have a lot of other examples. We had, because of course we are, let's say, our objective is to have less and less failures. So we had in the past a lot of examples, and the number of examples is getting lower because our operational are getting even better.
Yep.
We have more questions in the audience.
If I could, just tapping in on that. So we don't use the step change increase as the monitor, like, in the seconds, minutes time window. We're looking more for hours, days, and weeks with the APM solution. And we definitely have seen gradual rises for sure.
Yeah. So curious, you guys have talked a lot about the technology aspects. If you think about the people and process side, I wonder if you could touch a little bit. I think to all the examples, you got the 30-year operators who just know how stuff works, right? And that adoption piece, just curious across the team, how has that worked? What kind of adoption have you gotten, especially from those more experienced personnel?
Yeah.
I'll go on that one. So that was one of the things that getting adoption of, especially, you're handing a guy that's been in the plant for 40 years, you're handing him a tablet. And he goes, well, why would I use this? I have my notebook. And that was a very, for some people, it was a very difficult transition to move to that tablet. But what we found was that by going out and talking to them, and we spent a lot of time out in the operating units with each crew, going through, showing them what the device was, what it did. And what we did is we adopted the things that they were doing on a day-to-day basis. So we didn't completely flip the script on your 40-year operator. He was looking at the same things. He was just using a different tool to collect it. And we found by spending the time and being available and being out there with the operators and maintainers that were taking those checks, we had a lot better uptake on the technology that we were putting out there. Sold benefits to the guys in the field, how much more efficient it was, actually showing them how to generate a work order and how fast it was, that they didn't have to log into the CMMS. They didn't have to type what the equipment was or find the functional locations for these pieces of equipment. And it was selling those benefits to those operators that was able to increase the uptake. Now, don't get me wrong, there are certain operators out there that never really took to it and don't know that they ever will. But these are the same guys that they don't even like logging into the computer to get their email. And so it was something that we had to recognize and make sure that their supervisor was important to their supervisor. And it, just like I believe the last presentation showed, it goes down that chain. So if it's important to the supervisor, it's important to the people that work with them. So that's how we did it.
Can I add a story to complement that? I assume by long competence, you mean probably a generation issue. But one supervisor, mechanical supervisor, was working on a platform, a couple of diesel generator and 3 pumps. So he told us, I don't give a peanut for your smart signal things. But he get promoted and he landed on an FPSO, which means a large productional platform. And he get on the shoulder 3 turbo generators, 2 turbo compressors, 2 electro compressors, 3 water injection pump, 4 crude oil export pump, and another dozen of equipment. So he ended up with 130 equipment. And the months after, I had a call asking for deployment of those equipment into the monitoring center. So adoption may change depending on condition, but generally, it is a matter of as well of quantity of job. So sometimes it's hard, it's right, but generally it's okay. After a few years, it's okay.
I think I was going to say, your question, I think it's the most difficult part of the digital journey, the adoption part. So I think I'd break it down into worrying about, skilling, upskilling, reskilling, the examples that Nicholas gave. You have the users who are expecting, the younger, if you will, the tech-savvy, digital-savvy users who expect to have the device in their hand. But pretty large majority of our user base, is kind of wondering, like, why are you asking me to change the way I've been working for all these years, okay? And then you have a smaller portion of the people like don't want to do it because that's just the way it is. So I think the training, awareness, in yours, Mark, you talked about the leadership, like the leadership site needs to own that and drive the adoption. Messaging, it's not the IT systems and the people who developed it, right? And make sure that they have the tools that are needed, they're trained, retrained, and then the awareness, you're constantly driving that messaging. Otherwise, there is no value case to be, I always say there's no value case to be gained, if you implement it, but it doesn't get used, that's expected.
But sometimes we just need the general manager to say, you do it and that's all. I think that's one of your tips, right? We talk about adoption and things, this approach is okay, but once it is not working, we just need the manager, generally with one email saying you have to get to it, and afterwards we get the adoption right away.
The reason the leadership's so important is you will encounter resistance, and having a constancy of purpose that says, no, this is the way we want to go, we want to do it, it changes the game entirely. Mm-hmm. So just it helps a lot. And then patience.
Yeah, and I would say the step after is showing them that you will not steal their job, they will still be useful, and you are not telling them you are not performing well. It's just an additional support. We are looking after what you can't see because you are in your day-to-day operations.
So with that, it's time to wrap up the discussion. I know we have some pending questions. get a hold of these guys when they get off stage. So, but I really want to thank all the speakers, all the panelists. Great discussion. Thank you so much.